Hello everybody. Today we start one of the core topics of C++, which are if statements. So to motivate why you might need an if statement, consider the following scenario. You have written a game program that lets the user play one of three games: Hangman, Blackjack, or Poker. So the way that the program would probably start is that you begin by asking the user, which game would you like to play? I wrote three different games for you. Tell me which one you would like. So here's how that code would work, right? You create a string, or I guess a character if you want to just do a single letter, and then you record the user's response. You see what they wanted to play. Well, if the response is Hangman, you should probably do some Hangman code, right? You've written some code that lets the user play Hangman. If the response is Blackjack, you should do some other chunk of code that lets the user play Blackjack. If the response is Poker, finally, you should do some other chunk of code that lets the user play poker. So what you need some sort of branching in the program. You need some way of telling the computer, if this thing is true, like if they responded Hangman, go over here. If this other thing is true, like they said Blackjack, go over here. So a schematic of this visually is something like this. In this scenario, there are three possible branches the program could take. One branch goes to Hangman, one to Blackjack, one to Poker. The way that you get a computer to choose one of many possible options is with an if statement. Okay, so an if statement goes like this. If they say Hangman, go here. Otherwise, if they say Blackjack, go here. Otherwise, if they say Poker, go here. So today I'm going to teach you the syntax of that, and we'll work through several examples. So before I do that, we first need a definition of a Boolean statement, because if statements run on these things. A Boolean statement is a statement that's either true or, either true or false. So here are some examples. X less than 2. Depending on the value of x, that statement will be either true or false. If x has value 7, that statement is false. If x has value 1, that statement is true. Here is a statement that in this case is true, right? I am your professor. Examples of things that aren't Boolean statements are things like this, a greeting. There's no way that the word hello can be true or false. Or just the statement x. Not x is less than 2 or x equals 7 or something, right? Just x. That is not a true or false statement. Also, any kind of instruction, like, hey, perform this action for me. Right? These things are not Boolean statements. So if statements run on things like this. So you could tell the computer, hey, if x is less than 2, do blah, right? If the user response is Blackjack, do other thing. If I'm your professor, do this. So the word if, what must follow if, is some statement that's either true or false. And if that statement is true, you should do the if part. And if it's not true, you should just skip. So here's the syntax of an if statement. If, and then you put a Boolean statement in there, and then put whatever code you want, If that Boolean statement is true, then the program will do this code. If the Boolean statement is false, the program just skips right to this end brace right here. It will not do that code. It will pick up right here where it left off. So here are a couple of examples. Int x equals 2. Well, if x is smaller than 3, print to the screen, what up? Since this statement is true right now in the code, right? If x is 2 right here, then it's still 2 right there. 2 is smaller than 3. So this Boolean statement is currently true. Therefore, you enter the if statement, you go inside the braces, and you do whatever it says to do here. By contrast, this chunk of code prints nothing to the screen, okay? Because 4 is not smaller than 3. Therefore, the statement x smaller than 3 is false, and so you just skip right over this code right here. So the braces tell the computer what statements to run if the Boolean statement is true. Without the braces, if you don't write them, only the first line following the if statement is executed. So what that means is that the computer will put in some implied braces for you. So right here, if x less than 1, cout high, cout class. The computer will put braces around this because you haven't put any there. So what happens here is x is 2. 2 is not smaller than 1. Right? The statement x less than 1 is false. So the computer will skip over whatever is inside the if statement. There are implied braces here, so that is what is inside the if statement, just that cout high statement. Cout class, on the other hand, is not inside the if statement. So this line will run no matter what. It doesn't depend on the truth or falseness of that statement there. Okay, so if you want to have the computer run down several different branches, the way you do it is with first an if statement and then with else if or else statements. And here the word else is a bit of a misnomer. What you really mean is otherwise. So in this code down here, int x, and then you grab something from the user. If x is positive, you should see out, hey, your number is positive. This word else you read as otherwise. So what you read is, hey, otherwise, print to the screen, your number is not positive. So you've given the computer two separate branches to run down. The computer can either do this, or it can do this. It can't do both. Okay, it only goes down one branch. So I already have that code in my compiler. So let's just run this and see what happens. Okay, so I'm going to enter like a 10. It says your number is positive. Okay, unsurprisingly. It grabbed that number right here. 10 is indeed bigger than 0. So it prints this, and then it skips to the end. These two things here, this cout and that cout, those are two mutually distinct branches of the program. The computer cannot go down both. So it will do one or the other. So if I enter like a -5, right? Well, -5 is not bigger than 0, so this statement is false. Therefore, the code will not go into this line. The computer will skip this, and it will go right to the else, and it will print your number is not positive. Okay, so we have now created two mutually distinct paths that the program can take when it gets right here. It can either take this path or this path, and that decision is made based on whether or not this statement right here, this Boolean statement, is true or false. So if you want to give the computer a bunch of different branches, these are just two branches, right? You do this or you do this. If you wanted to give it a bunch of branches, the way you do it is with an if, else if, else if, else if, else setup. So you can put as many conditions on this as you want. And have the computer go down as many different branches as you want. So let me show you how that works. So let's think about that game example I started with in the beginning. So string response, let's just get the response from the user. So there were 3 games. There were Hangman, Blackjack, or Poker. So we can set up something like this. If the response they give me is whatever, Hangman, then you would have your Hangman code here. We currently don't know how to program Hangman, but let me just put something there. Okay, but what if they don't say Hangman? What if they say Blackjack? Well, then you can say, well, otherwise, if their response was Blackjack, then do the Blackjack code. And again, we don't currently know how to program Blackjack, so let me just put something here as a placeholder. Okay, well, what if they don't say Hangman? What if they don't say Blackjack? Well, if their response finally is Poker, then, again, let me just put a placeholder here, Poker. Okay. So what's the logic that's happening here? You have now given the computer 3 separate branches that it could go down. If they say Hangman, it could go down this way. If it says Blackjack, it could go this way. If it says Poker, it will go this way, right? If response is Hangman, do this. Otherwise, if response is Blackjack, do this. Otherwise, if response is Poker, do this. Okay, so I'm going to run this in a second. You may notice these little caution symbols or something here, right? The computer's not completely happy with what I've done. I'm going to talk about this more in a second, and let me warn you, this will bother you. You can't just put in equals here because this is supposed to be a Boolean statement. So if you just have a single equals, what you're saying is, hey, it's like an assignment equals, as we've previously discussed. What you're telling it is, hey, set response equal to hangman. But set response equal to hangman is not a Boolean statement. Okay, as I mentioned a few minutes ago, doing something, like telling somebody to do something, giving them an order, is not a statement that's true or false. Whoops. So when you use equal signs inside of an if statement, you have to use a double equals. The double equals is called a Boolean equals. Now, you've basically turned this into a question. Does response equal hangman? And if the answer is yes, you'll go in here. If the answer is no, you will move on. So this now is a Boolean statement. Response equal hangman. True or false? And you can test. So that's why it was yelling at me. Okay, so let me just run this. Let me type, I don't know, poker, right? And it tells me poker is what I chose, right? So it tested this statement, saw it was false, tested this statement, saw it was false, but this one was true, so it went in there. So there are several things you can note about this. I'm not going to note them all because of limited time, but maybe I misunderstood the games you programmed. I'm going to type chess. Notice it printed nothing, right? Because chess isn't hangman. Chess isn't blackjack, chess isn't poker. So it just skips over all these conditions and then we're done. If I take this if off of there, so now it's just an else statement at the end, and else is without an if, right? Just plain else never comes with a condition. Else is just a catch-all for anything that wasn't caught by the first branches. So now if I type chess, what happens is, well, chess isn't hangman, skips. Chess isn't blackjack, skips. If you end your branching with an else, the else will catch anything that was not caught by previous branches. So if you end your if, else if, branching, whatever, with an else and not an else if, the program is guaranteed to go down this branch if it did not go down a previous branch. So the way you really might want to set this up is like this. Okay, else if response is poker, then do your poker code. There's one last condition you might consider, which is that they entered something you don't recognize. So you could say, well, I didn't see hangman, didn't see blackjack, didn't see poker. So you might want to tell them I didn't understand what you just said. This program only has 3 games. So now if I type chess, it says invalid input. Chess is not hangman, not blackjack, not poker. So then we enter this last branch down here. Okay, so that's how if, else if, and else's work. It's like anything, you have to use it yourself several times before you get totally comfortable with it. But the basic picture is this. You are giving the computer several mutually distinct options it could take, mutually distinct paths. So just to emphasize the mutual distinctness here, let me show you one more example. I'm going to set x equal to 10. And now I'm going to say, hey, if x is bigger than 8, okay, then print bigger than 8. Okay, well, otherwise, if x is bigger than 6, well, you get the idea. Let me just do one more. Else if x bigger than 1, cout bigger than 1. Okay. So the question is, if I run this, what will the computer print to the screen? Because if x is 10, if x has value 10, well, this statement is true, isn't it? 10 is bigger than 8. So the computer will definitely print this. But 10 is also bigger than 6, isn't it? So this statement is also true, as is this one, right? 10 is bigger than 1. So all of these conditions are met. So you might think that the computer will run all of these statements. You might expect the computer to print all 3 of those statements, but it doesn't. It only prints the first one. That is because these branches are mutually distinct. That is how the if and else if structure works. You can only go down a single path if you're going to use this syntax. So notice if I put a 7 right here. Now what will happen, 7 is bigger than 6, 7 is bigger than 1, isn't it? This statement, though, is false. 7 is not bigger than 8. So you skip. Here's the first time we get a true statement. So then we do what is in that branch, and then we skip to the end. Right? We don't go down this branch because we can only go down a single branch. Notice, though, if I take away the otherwise from these statements, right? This used to be if x is bigger than 8, blah. Otherwise, if x is bigger than 6, blah. Well, now there's no otherwise if right there. It just says if x is bigger than 8, do this. If x is bigger than 6, do this. If x is bigger than 1, do that. It just keeps going like that. If you take away the word else, you have now not created mutually distinct paths for the computer to flow down. Because now when you do this if statement here, there's no else if at the end of it. So it's done. That if statement is done. Same with this one. So really you're just giving it this option to go down or just keep going. So subtleties like this take some getting used to. You have to use these things several times. But this is the basic structure. These are all mutually distinct. But again, if I take the word else out of this picture and you just have if, now they are no longer mutually distinct. Now you aren't even branching anymore. Okay, so there are lots of Boolean words that you might want to translate into English. We've been using greater than and less than and equals. We already discussed equals. If you want to do greater than or equal to, sorry, not greater than or equal to, it's a greater than symbol with an equal after it. Less than or equal to is a less than symbol with an equals. Not equal is an exclamation mark followed by an equals. And so just for emphasis, okay, don't confuse double equals with equals. I'm telling you this, but I guarantee you will forget. That's fine, right? There are lots of things you forget until you have done them multiple times. But just to reinforce, if you write this, that's a Boolean statement. It's going to test whether or not x equals 2. This is not a Boolean statement. It's an instruction. You're telling the computer to assign the value of 2 to x. So what usually happens is if you write something like this, you're going to just set the value of x equal to 2 and then just run whatever's inside the if block. So you're not giving the computer an option because the statement's not Boolean. Okay, so at the end of this video here, you should be comfortable with the if and else structure, the branching structure. You should be able to use these symbols as we did in the video. You should be comfortable with a basic let's say 3 or 4 branches as in our hangman, poker, blackjack example. So next time what we're going to do is just, next video anyway, we will build on this if statement stuff. There's plenty more to do with it, so we'll have an if statement video 2 coming up next.